Hello everyone. Today we are going to discuss about the Euler's theorem. Well, it is valid for homogeneous functions. Okay, I already discussed about homogeneous functions. What are homogeneous functions? How to find the degree of homogeneity. Okay. Euler's theorem states that if a function is homogeneous, say whose degree is n, and we are taking only in two variable system, that is in x and y, is continuous plus second order differential or say derivative, then it follows two conditions. First one is x into partial derivative of function with respect to x and y into partial derivative of a function with respect to y gives what? nf, that is n degree of homogeneity, and multiplied over the original function or the given function. As simple as that. And why it's need, why Euler defines this theorem. See, many times you have given a function and you have to find derivatives of it, and mainly the partial derivative. Here is with the sign of partial differentiation, and it will become too lengthy for the sine inverse, say sine inverse x plus y plus something under root. There you go. And Euler's define for the same that you don't have to derive everything, you just have to put the formula and get your result. Okay. For the same, the second is x square del square f by del x square plus 2xy into del square f by del x y plus y square into del square f by del y square. That is, previous one is the first order partial differentiative. This one is the second order partial differentiative, which we encounter as if you have to find second order partial differentiation of a function, you will just define it as in an easy way that you will get its result n into n minus 1 and multiply with the original function. Simple. Now let us take a look into its derivation, which is quite easy. Now first condition is for the Euler's theorem to satisfy that a function is our given is should be homogeneous. How it is so? A function is homogeneous if we satisfy this equation also. We are not encountering with lambda form because this is a basic one. This says this is a replace of a constant, so it will not help much. And our second form to define the homogeneity or the homogeneous function is this one. Okay, let us take it into consideration. This is a homogeneous function. Okay, our f is a homogeneous function. Now partial derivative both sides with respect to x and then y. When we partial derivative the function with respect to x. What we get? This is the function with respect to x. Okay, both the function carries action, so we define our product rule. For the first one, power comes after it and one less, and second function as it is, plus now the first function is as it is, derivative of the second one, derivative of this one, and inner functions are y by x, derivative with respect to y, so it will become minus y by x square. Okay, this is our function derivative with respect to x. Now we derive with respect to y. When we differentiate it with respect to y, this is a constant. Okay, x is to power is a constant only. This one is a what? Variable. Okay, derivative of this function, inner function become it is a constant y. Remove this power and 1 by x remains. Now our first form was like of Euler theorem, that x into multiplied by the derivative of the function with respect to x plus y into derivative of y. Okay, you remind it? Our first form of Euler theorem is like that. Now why it is so? Let us check it out. When we multiply with x, we get x raised to power n, okay, and x raised to power n gy by x plus, here what we get? Okay, the function first time is cut out, their power when n minus 2, this is not plus, this is minus, and y, one more power is added to this, will become n minus 1 into g dash y by x. This is for the x, and for y is multiply with the partial derivative function as y. So we get y by x is to power n minus 1, see that, into g dash y by x. You encounter this, both will be cancelled out, and what remains? X is to power n gy by x. This was your original function. See here n, and this was your original function n. Quite easy. That's why Euler define it. It is a easy formula to less your calculation of the partial derivatives. You don't have to fully partial derivative the function of such a big function. This is the ease of it, or say its application. Second one, Euler's theorem. How we derive it? With the help of first one. Now let us discuss how we derive the Euler's theorem second form. With the help of the first one, which we have already derived, we just have to do that. We have to again partial derivative both sides, okay, with respect to x and y. We will get our result easily. First, with respect to x, what do we get? X as it is using product rule plus del f by del x, differentiating y it is as constant, so it will remain outside, and del square f by function will be derivative with this is a constant and derivative with respect to x, so del x equal to n del f by del x. Because this function is a two variable system, that is in x and y, so it will be treated as variable both in the cases. Now with respect to y, x is constant, del square f by del x remains same, and del y plus y as it is, del square f by del y square plus y will remain, del f by del y remain same, and y derivative is 1, and here del f by del y. We were getting this, we have to just multiply this term with x and this term is y, because in our result we encounter with something x square and 2xy. When we multiply with x, here what we get, x square del x square y del x square del f square y del x square, and with y we return, here is return, first we return them, we will add both of them. Okay, x square del square f by del x square plus from there y square del square f by del y square. Okay, now this term xy into del square f by del y and del x, these both terms are same, so we just simply say 2xy del square f by del x del y. Now these term and these term are left and right hand side are left. X del f by del y, it will become del x, and it will become y del f by del y, and we are adding them, it will, n will be common or they will become same term, so n will be common and minus 1 will be there, and you get the same. Okay, something is missing. Yes, x and y are missing because x is multiplied both the side now. And what is that? This is our original function, that is nf. So n into n minus 1 f. This is a simple formula of twice derivable, partially derivable. Okay. However, we can also define partially three derivative function. It seems so, but we will just define only the two of them. Let us take some example, it will be quite clear. Our example is, you have given a function u. That's to differentiate two variable system is cos inverse x plus y by root x plus root y. Then we have to find x del u by del x plus y del u by del y. What will be its value? Now to apply the Euler theorem, first we have to check whether it is a homogeneous function or not. Then we will further move. Okay. How we check? It's one way that you replace the function with lambda x, lambda y. But here you check, here you see that cos inverse is not getting the same because you can't get it. The reason is cos inverse will be in front of it. Now what will you do? there is one way that let us take cos double this side, means taking cos both side, cos you get x plus y by root x root y. Now this is a differentiable function. Say let us take x common from here, plus y by x without regards of our first form of homogeneity. We are going with the same one. Here we get another function, say g, which is in the variable of y by x, and x raised to power 1 by 2 g of y by x. Then this is a homogeneous function with homogeneity is 1 by 2. This therefore we get value of n equal to 1 by 2. But we get this function with respect to cos u. You should always know in your back of mind. Okay, what will the result with respect to this function? Applying the Euler's theorem, what we get, because we can't directly apply the for u, because this is for cos u. Cos u is a homogeneous, not u. We get nf, that is our first theorem of Euler's. N is 1 by 2. What was our original function? This was our function. Now we have to find del u by del x. So just derivative it. What is the derivation of cos u? Minus sin u. What we get? Del u by del x plus y minus sin u del u by del y equal to 1 by 2 cos u minus sin u common, and you get, taking it to the right hand side, you get minus 1 by 2 cos by sin is cot minus cot u. So this is our answer.